In grade 11, we became used to using these equivalence statements. For example, F equals ma to solve problems. And provided you were careful about the way you designed your force unit, in this case we always use newtons, which mean kilogram meters per second squared, you could make an equivalence statement. But if you're experimenting for the first time, you're probably going to be finding things out that nobody knows, and there aren't any equivalence statements for them. And so you might say to yourself, well, I'm going to experiment with force and mass and acceleration and try and see how they're related. If you held acceleration constant and changed mass, what you would find out is that force varies proportionally with mass. And so really what you'd be saying is, if I want to achieve the same acceleration, I'm going to have to apply a greater force as the mass increases. So we would say that force varies directly with mass. If I double mass, I have to double force. Similarly, if I hold mass constant and I want to see what happens when I get a bigger acceleration, I would find that I would need to double my force to double my acceleration. And so once again, I'd be saying that force varies proportionally with acceleration. On the other hand, if I were looking at the relationship between mass and acceleration, provided I hold force constant, I would find that mass varies inversely with acceleration. And so if I were changing my mass, I would find that as my mass goes down, my acceleration would go up, provided I held force constant. You're going to be dealing with data and finding out what that data says about the underlying proportionalities.